Hey, all you crazy chemistry kids. We're going to try to do a lab where I can show you a little demonstration of stuff. And then I'm going to try to edit some video. This is my first foray into this. Let's see how it works out. What we're going to do is I've got a piece of filter paper and a wife crawling underneath me. I got a piece of filter paper with 4 colored dots. You'll see there's a black, a red, a green, and a blue dot. What we're going to do is we're going to submerge it into a beaker. This is like my really cool coffee mug. A beaker with a little bit of water at the bottom. And what will happen is the water will travel up the filter paper. And what it will do is, since we're looking at solutions, we've got a solute being this water-soluble ink and the solvent of being the water. And I have my assistant. Here's my little assistant, Hannah. As it goes into the water, it will cause, the paper will, like, you know what happens when water gets onto paper, it spreads out. So the water is going to go on the paper, it's going to spread out and start going up through the piece of paper, and it's going to take that stuff with us. So when we get done with a time-lapse video, I'm going to try to splice these together, and we'll see how it worked out. And then we have a couple questions for you to answer once we look at the final result. All right, here we go. All right, so at the end of that, you saw that the solution caused the colors to move up on the piece of paper. Here's what they actually look like now. I'm going to try to make this work with my camera. So this is an old one. This one I did on Saturday as an experiment just to see if it would work. But here was today's. And you'll notice I started with the dots way down at the bottom, like down here, and they started to travel up. What do you notice about the black from left to right? They went black, red, green, and blue inks. So what did you notice? Is there some relationship to solubility? Because notice the yellow didn't go as far as the blue. Notice that in the black ink, we have lots of different things going on in there. So a couple questions again for you. Just why do some move differently than the others? And does the separation of the color mean anything in terms of things we've already talked about in chemistry, like solubility and intermolecular forces and things like that? So the other thing that we talked about the other day, and I had to get my daughter to come be my assistant. I don't know where she ran off to. Is we're going to talk about when you add Kool-Aid packet into water. So she's getting herself all disguised because she doesn't want anybody to see her. And what we're going to do, I'm going to take the camera back. She is going to get a packet of Walmart Kool-Aid and a water bottle that's already open, so don't spill it.
Okay.
You're going to open it and you're going to pour it in, but you're not going to shake it. And here's the disguise. So you got to show everybody. Okay. You're not going to shake it. You're just going to pour it into the bottle for us. And then we're going to watch it. What's going to happen, boys and girls, as we put this in, what happens in terms of solubility? Why do you think it's important for us to shake it most of the time? So we've added these things in. We've added this powder into our liquid. You can kind of still see here at the top, there's a little bit of the powder just kind of sitting there. It didn't dissolve all the way in. Let's see if we look straight down on it. Nope, doesn't look any different. So what's the difference that when she takes the lid, puts the lid back on, and now shake? What are we doing when we shake this up? Why is this an important process in making a solution? Set it back down, please. Thank you. And now all of our solvent has mixed in with the solute. We don't have any mixing parts, and we now have a solution of purple drink. Grape, fake grape, Kool-Aid, whatever, Walmart version. So what we're starting to see is there are different ways to speed up the solubility. So on this, the ink, all we had was the piece of paper was the medium that allowed the water to travel up, and it caused a solution that those water-soluble inks spread out. In our solution of a beverage, what we've done is we added solute to the solvent, and it's going to dissolve because the powder that is made out of is really, really fine a lot of it dissolved like right away. As soon as she poured it in, it was dissolved. But why do we need to shake it? That was one of the 3 things that we have to be able to speed up the process of a solution being produced. All right. So hopefully throughout this whole thing, you're starting to realize that sometimes there are, that's the 12-year-old. Sometimes there are ways that we go about making solutions that help things out. What if we had used hotter water? Again, this was kind of room temperature water. If it had been cold, might have done something a little bit different. What if we had used ice cold water, not frozen, but like really, really, really cold? What if we had used milk with like Nesquik or something like that? It will take a lot longer for those solutes to dissolve into the solution. So those are your demos for today. That's your little fake lab. I don't have any questions to go with it yet. Maybe I'll try to put something together and put it into one of our Moodle assignments. But that's your information for this couple of days this week. I'll have some more stuff posted for you later this week. Have a great afternoon.